Have you ever looked at a map of the world and noticed something peculiar? Look closely at the coastlines of South America and Africa. Don't they seem to fit together like pieces of a giant jigsaw puzzle? This intriguing observation has captivated the minds of explorers and scientists for centuries. Could it be that these land masses were once united? And if so, what force could have possibly ripped them apart? The idea that continents might have moved throughout Earth's history is not new. However, it wasn't until the early 20th century that a young German scientist named Alfred Wegener dared to propose a revolutionary theory. He called it Continental Drift. Wegener's theory challenged the long-held belief that continents were fixed in their positions. He argued that the continents were once joined together in a single supercontinent and had slowly drifted apart over millions of years. This notion seemed outlandish at the time, met with skepticism and even ridicule from the scientific community. How could massive continents possibly move across the Earth's surface? Wegener knew that to convince the world he needed strong evidence, and he had plenty of it, meticulously gathered through years of research and observation. Alfred Wegener was a man of diverse scientific interests, a meteorologist, geophysicist, and polar researcher. His fascination with the possibility of continental drift was sparked by his observations of the world map and his deep understanding of Earth's geology. He saw beyond the seemingly fixed nature of continents and envisioned a dynamic Earth where land masses could shift and move over time. In 1915, Wegener presented his groundbreaking theory to the world in his book The Origin of Continents and Oceans. He argued that around 200 million years ago, a supercontinent he named Pangaea, meaning all lands in Greek, began to break apart. Over millions of years, the fragmented pieces, which we now know as continents, slowly drifted to their present positions. Wegener's theory was revolutionary, a radical departure from the prevailing scientific dogma. It challenged the established knowledge of his time and presented a bold new perspective on the Earth's history and the forces that have shaped our planet. Wegener's theory was not merely a product of observation. He meticulously gathered scientific evidence from various fields to support his claims. His evidence came from the fossil record, the geological formations, and the ancient climates preserved in rocks across different continents. He found identical fossil species on continents now separated by vast oceans, suggesting that these landmasses were once connected. One of his most compelling pieces of evidence came from the discovery of fossils of the Mesosaurus, a freshwater reptile that lived during the Permian period. These fossils were found in both South America and Africa, continents separated by the vast Atlantic Ocean. Mesosaurus, being a freshwater creature, could not have possibly swum across such a distance. This suggested that South America and Africa must have been joined during the Mesosaurus's time, allowing the reptile to roam freely across both land masses. Similar patterns emerged when Wegener examined the distribution of plant fossils such as the Glossopteris fern. This fern thrived in a cold, temperate climate, and its fossils are found in Antarctica, Australia, India, Africa, and South America. The presence of Glossopteris fossils on such widely dispersed continents, now with vastly different climates, further strengthened Wegener's argument for a once-connected landmass. Despite the compelling evidence presented by Wegener, his theory of continental drift was met with resistance and skepticism from the scientific community. The prevailing view at the time was that the Earth was a solid, unchanging body. Wegener's idea that continents could plow through the ocean floor was deemed physically impossible by many prominent scientists. One of the main criticisms leveled at Wegener's theory was his inability to provide a mechanism for continental drift. He couldn't adequately explain what force was powerful enough to move continents across the Earth's surface. Without a convincing explanation for how continents could move, his theory was considered incomplete and therefore not widely accepted. However, Wegener remained convinced of his theory, believing that future discoveries would vindicate his work. He continued his research and exploration, tragically dying during a Greenland expedition in 1930. Though his theory faced initial rejection, it laid the groundwork for the future development of plate tectonics, a theory that would revolutionize our understanding of the Earth.